Okay, so welcome to the Unit 4 Lesson 7 video on solving polynomials using algebraic theorems. So in this lesson, we're going to kind of talk about the theorems and that have been kind of guiding our process so far and kind of tie it all in together for solving some more kind of complex problems. So the first thing we're going to talk about here is the conjugate root theorem. All right, and we've talked about this before. You've seen this before. It just states that if a polynomial has rational real coefficients, but has irrational roots or imaginary roots, then they're going to occur in conjugate pairs, right? A plus the square root of b and a minus the square root of b, a plus bi and a minus bi. So if you see one of these two roots, you have to know that the other one is going to exist. Right? So if we're looking at this example here, and it says the quartic polynomial, quartic, right? So that means 4, right? Fourth degree, has a rational coefficients, right? So that's our criteria, it's rational. So I have -3 plus square root of 2, so I know that there's another root that's -3 minus the square root of 2. And then it has this imaginary root, so I know its conjugate also is a root, which is 1 plus I. So I knew there was 4. They gave me 2. I found the other 2 using the conjugate root theorem, right? And that's pretty much just be able to make sure you know how to find conjugates, right? The next one here we're going to talk about is the remainder theorem, right? So last class we did a lot of division, right? We did synthetic division and we did long division. And so this remainder theorem, notice it doesn't say synthetic or long. So anytime you divide a polynomial of degree greater than 1, right? So we're talking about quadratics, we're talking about cubics, quartics, quintics, like anything higher than a linear term by a linear term, then the remainder is P of A, right? So what does that mean? Let's kind of take a look at an example, and hopefully this will become a little bit clearer to your understanding, okay? So here's a division problem. It's asking me to divide by x minus 1. I'm going to synthetically divide that, and I'm just going to work over here. 1, -5, 7, -5. Okay, and so since I'm synthetically dividing, the 0 of x minus 1 is positive 1. So when I synthetically divide that, bring down my 1, multiply, combine -5 and 1 to get -4, multiply, and I get -4 again. Combine 7 and -4 to get 3, multiply, and I get 3. Combine -5 and 3, and I get -2. So, in fact, x minus 1 is not a factor of the original polynomial. 1 is not a 0. My remainder, right, this remainder here of -2 is actually the same thing as P of 1 will be -2. That's the remainder theorem. Tells me that if I synthetically divide by 1 and I get a remainder of -2, then if I plug 1 into my function, right, P of 1 is equal to 1 cubed minus 5 times 1 squared plus 7 times 1 minus 5, I should get -2, right? So let's check that out. 1 cubed is 1, 1 squared is 1 times -5 is -5, 1 times 7 is 7, and then minus 5. So that's -4 plus 7, which is 3, minus 5, which is -2. So in fact, when I plugged 1 into the function, I did get -2. So that's just, again, just a verification of the remainder theorem. And so an interesting point about this, just to tie it all together, that means that the point 1 comma -2 is a point on the graph of P of x, right? So if I was to graph this function and go to the point 1, -2, I would be on the graph, all right? Again, that's the remainder theorem. Pretty straightforward, but it's important that you know what it's called and you can easily access it. And we'll practice that some more in the classwork, all right? And the last theorem we're going to kind of talk about here is called the rational zero theorem. The rational zeros theorem is what you use to be able to figure out, if I don't tell you what to divide by, it's what you use to figure out what can I divide by, right? And it says that a polynomial with integer coefficients has rational zeros of the form p over q, right? So p is the constant term, right? And q is the leading coefficient. So a polynomial, let's say p of x, we'll call it f of x not to confuse you, would be q x to the third plus p, right? So p is the last term with no x's on it, and q is the first term, okay, the leading coefficient. So what does that look like in actuality? Here is my p, and here is the q. All right, so if I was to list this out, and we have to consider also the positive negatives, right? Because all of these factors could be positive or negative, right? So if we're factors of 7, I have 1 and 7. Those are my only two integer factors over the factors of 4. 1 times 4 and 2 times 2. So with those factors listed out, I now need to be able to make a list of all my factors. So plus minus 1 over 1, plus minus 1 over 2, plus minus 1 over 4, plus minus 7 over 1, plus minus 7 over 2, and plus minus 7 over 4. So these are possible rational zeros, right? They are not actual rational zeros. They're only possibilities. These are the numbers that I would check if I was to synthetically divide 4x to the fourth minus 2x squared minus 7. I wouldn't synthetically divide by 2 because that's not a possibility down here. 2 is not listed in here. I would start with positive 1 and then check negative 1. I would probably check positive 7 than negative 7 because it's easier to multiply by 7 than it is by like 1/4, right? But you just kind of go through that list, and we'll see that example on the next page. But for a second, take a moment to pause the video and try number 1 on your own. See if you can list out all the possible rational roots for this function here. All right, pause the video, give it a try. Okay, hopefully you paused that and gave this a try on your own. But you should end up with these 8 different possible rational roots. Plus minus 1 is 2, plus minus 2 is another set of 2, plus minus 4, and plus minus 8. All right, so that's finding rational zeros. And now if we go to the next page, we'll kind of see, put all this kind of together and figure out what we'll do when given a polynomial and asked to find all the zeros. That means real and imaginary algebraically. All right, so I see that the leading degree is 4th degree, so that means there will be 4 zeros total. If I don't come up with 4 zeros, real and imaginary, then I've done something wrong, right? So now, what are my possibilities, right? What are the possibilities? So I'll look at plus minus 1 and 2, because that's my last term. divided by my leading coefficient, which is 1. So my possible zeros are 1, -1, 2, and -2. So those are possible. Those aren't my zeros. They're only the possibilities of the real rationals. So let's give it a try. So now that I know what I can synthetically divide by, I'll just start with kind of the easiest number to start with. So let's set this up. 1, -3, 3, -3, 2. Synthetically divide by 1 first. Bring that down. Okay, 1 worked. That is one of my zeros. Now you have to think about multiplicity, right? Maybe it works again, right? It could be a multiplicity of 1. So let's just double check that. Let's just go ahead and synthetically divide it again. This 0 doesn't count. So bring that 1 down. Okay, so I didn't get a 0 this time. So 1 only works once. So I don't need to check it anymore. So let's check -1. So let's recopy where I was before, which is 1, -2, 1, -2, right? And let's check -1 now. Nope, doesn't work. So I can mark that off because it's not a 0. All right? So this is not helpful at all. We'll come down here and rewrite it. And let's check our next number, which in this case I'll try 2. 1, so that's 2, that's 0. There we go. There's my remainder of 0. So 2 is another 0. Okay? So there are 4 total zeros. I have found 2 of them. I have one more possibility of -2, but that would give me 3, which would make 1 imaginary or 1 irrational, which I can't have only 1 imaginary or 1 irrational based on the conjugate root theorem. So I don't even need to check the -2. I know that that can't work. And I don't need to check it because this is the same as x squared plus 1. So since it's a second degree, it's quadratic, I can now set that equal to 0, and I can solve from there. So you want to synthetically divide until you get down to a quadratic factor, a quadratic polynomial, so that you can either factor or solve, set it equal to 0 and solve from there, or use a quadratic formula. In this case, I'm just going to solve it by subtracting 1 on both sides to get x squared equals -1. And then I'll take the square root on both sides, and I get x equals plus minus I. Okay, so there's 2 more factors. So the factors that I have so far give me x equals 1, 2, positive I, and negative I. So I said that there would be 4 zeros, 4 roots, 4 solutions, and I have found all 4 of those roots. 2 real, 2 imaginary. Okay? So the last thing we're going to do here is using our calculator. Okay? So hold on 1 second while I bring up the calculator. Okay, so I have my calculator here, and I don't have anything to synthetically divide by. I could do my possible rational roots, define what they possibly are, But with all the factors of 12 and all the factors of 2, there's a lot of possibilities out there. So instead, since this is a calculator activity, and if you see a question like this on the calculator portion of the test, here's a nice, quick, simple way to get down to the meat of what you need to do. Type it into the calculator under y equals, right? Y equals 2x to the 4th power plus 5x raised to the 3rd power minus 10x squared plus 5x minus 12. All right, and now just take a quick look at the graph, and I can see clearly that it crosses right there. There are 2 of my 4 real zeros. So how do I figure out what those are? Well, use second calc 0, right? Come on over here to left bound it, right? So and there's my first 0. So I know that x equals -4. Let's bring that back up. And let's do the second one here. So second calc 0. Come on over here to the other side. See, my y value keeps getting closer. Let's go there. Left bound, right bound. I know I crossed a 0. And there's my second 0 of x equals 1.5. All right, so I have those 2 rational zeros. So now I'm going to synthetically divide 2, 5, -10, 5, -12. And I'm going to synthetically divide by -4. So that's a 2, that's a -8, so -3. That's a +12, which gives me 2, which gives me -8, -3, and then +12, 0. I knew that -4 was a 0, so it shouldn't come as any surprise that I got a 0. And now I'm going to synthetically divide this by my other 0, 1.5, sorry, no, it's positive, 1.5. 2 times 1.5 is 3, so that's 0, which is 0, 2, and +3, which is 0 again. So that makes sense. That checks off like I expect. And I end up with 2x squared plus 2 equals 0. Okay, well from there, it's quadratic, so I can subtract 2 on each side. 2x squared equals -2. Divide both sides by 2. And end up with x squared equals -1. So x equals plus minus I. And again, this was a 4th degree polynomial. I used the calculator to find 2 of my real zeros, and then I used those to synthetically divide, getting me down to 2x squared plus 2. And from there I solved algebraically to get my 2 imaginary solutions, which are conjugate pairs. And that's all 4. So hopefully this was informative for you and clear. Bring any questions you have to class. None of the stuff that we did on here will be on the quiz. So prepare unit lessons 4, 5, and 6, and then we'll practice this after the quiz, and we'll move on from there. Have a great day.